Everyone, so this time we're going to go into some very special cases of motion. For example, if the particle moves along a straight line, well then our center of curvature is at infinity. Wonder why? Because in geometry we say that all parallel lines intersect eventually at infinity. Why? Because magic. This is just some sort of mathematician magic, but it works really nicely for these equations because it makes our normal component 0 and makes our whole acceleration equal to the acceleration in the tangential direction. Now if it moves along a curve at constant speed, well then we don't have any tangential component to our velocity. We simply have a normal component. Because our normal component is going to be the one that is turning it. This is something you would see if you have a satellite going around the Earth. It goes around the Earth at a constant speed, it is just constantly changing direction as it goes. Another option is that the tangential component of acceleration is constant. So our constant acceleration, well, then we get something very similar to what you've seen before. These are only for the tangential direction, but what you get is that it looks a lot like our projectile motion equations. It's not the exact same, but it's very, very similar. Okay? Very similar to our projectile motion equations. And why are they connected? Because projectile motion equations came from having this constant acceleration. And the last one would be the particle moves along a path which is expressed by this function. And therefore we can calculate our radius of curvature rho at any point as this. Okay, you don't need to memorize this, but write it down. Make sure you remember this point because there are a couple problems I'm going to throw at you later on, possibly on an assessment, where you have to do this. And if you don't remember it, it's going to be quite frustrating. So I'm bringing attention to it now. I'm telling you to focus on it so you don't have any issues with this. Okay. Don't forget, write it down. It's going to be a homework problem that has this, possibly in a quiz problem. So be ready for it. Now, one last thing we're going to hit on before we do some examples is three-dimensional motion. So we have a particle and it's moving along a space curve. Well, the NT axes are defined as before. The tangential one is towards the path of our tangent to the path. The normal one is towards the center of curvature. But then we have this third direction, x, y, and z. Well, in this case, it's called the binormal direction. Okay, it's the binormal direction. And it's simply found by taking the cross product of our other two unit vectors. However, there is never any motion or velocity or acceleration in the binomial direction. Sorry, I said binomial direction. So it's really kind of pointless, which is one thing that's very nice about using the normal and tangential system, because even in 3 dimensions, it still works really, really well. Well, that is it for this time. So next time we're going to jump into some examples going over how to use these normal and tangential components, and we'll really knock it home. If that doesn't make any sense to you, please just ask questions next time in class and we'll go over it together. Have an absolutely wonderful day. Bye.